We are talking about compositions of functions today, and I'm going to show you a few that we're going to be on Delta Math in just a second. So a composition of functions is where we take a function and plug a whole function into another function. And so we have some notation, and this is the notation that they use now. It's F with a big O, like a circle G, F circle G, I think is usually how we say it. But it really means of, that is F of G, in terms of X. And I hate it looks like fog, I know it is a little bit weird, but it is F of G, that's how you read it, F of G. And again, this is notation that wasn't around when I was in high school. It wasn't what was used. And so what we used and what this means is that we have an outside function F, and on the inside, we're plugging in the G of X function. All right, so we're taking an entire function and replacing the X in it. Okay, the domain is pretty tricky. I'm not going to spend too much time on it, but it's easier to talk about graphically. So this is F of G. It means F of G of X, and it can go both directions. You see here we have F of G, but then here we have G of F. All right, so the order matters here. Let's see, how do I want to do this first? So I want to turn the page, and we're going to start here on example 6 and 7. Oh, yeah, okay.
You push that trigger when it's
Well, even like how she wrote it, it's like, 6, 7, okay. All right, so we want to given f and g functions here, we want to evaluate each function. And again, we have the word value in here, so we're looking for a number answer. And I don't like this notation. It's no bueno, okay? So f of g of 3 means f is on the outside, and g of 3 is on the inside. So this is f of g of 3, and that's usually how we read it out loud. F of G of 3. So you can see how I'm color coding things. Now, what we have here are multiple sets of parentheses. And if we have multiple sets of parentheses, we always start on the inside here. So the first thing we want to figure out is, hey, what is G of 3? So what is G of 3? How do we do that? It's 4. How'd you get 4? Yeah, right here. We go to our G function, and we plug in the 3 in place of the X, and so we get 4. And so what I'm going to do then is now I'm replacing G of 3. I know what it is. And what is G of 3? It's 4. So I'm replacing G of 3 with its value. It's actually a 4. And now this tells me to do the next thing. So now it says, hey, go to the F function, and what does it want me to do? Plug in 4. So I'm taking the answer from G and plugging it into the F function. And so I'm going to go to my F function here and plug in the 4. So we have the absolute value of negative 2 times 4, which is what? It is 8. Okay. F of G of 3 equals 8. We are done right there. Okay. All right. It's not that bad. It's just one step at a time. And let's look at this one. So G of F of negative 5. So my outside function is the G. And then the inside would be F of negative 5. So once again, we're going to start on the inner function. And so I'm going to figure out F evaluated at negative 5. What is my F function evaluated at negative 5? It is 10. Good. So the absolute value of negative 2 times negative 5, that'd be a 10 right there. So So we get 10. All right, and so it says, hey, f of negative 5 is really 10, so I'm going to plug it in. So g, what is f of 5? Or sorry, f of negative 5? So it's really 10. And then we want g evaluated at 10. And what is g evaluated at 10? Yeah, that's just 11. So 10 plus 1 is 11. So that is just 11. Very easy. All right. Does that make sense to you?
Yeah.
Okay. Let's try these. No, it's not. Let me go to the computer. So I'm going to pause the recording, and I'm going to show you a couple on the computer that you're going to see. So I'm going to pause this. All right. So now that we get that, let's go back, and now we do the more algebraically intense things. All right. Now the nice thing is Delta Math doesn't overburden you with domain problems, so I'm not going to talk too much about domain. But I do want to say, graphically, when you're looking at those graphing ones, what happens if, let's say, I'm just going to draw one for right here. Okay, let's say we were doing a graphing one. I wish I had a little space here. Here's the f function, and let's say it looks like this. Okay, and here's the g function, and let's say that it looks like absolute value graph. And if you had the composition g of f of negative 2. G of f of negative 2. Well, just like what we just did in Delta Math, f of negative 2, I'd have to go over here. Can I figure out f of negative 2? No, why not? It isn't there. Negative 2 is over here. There's no graph. It's not part of the domain. And because there's nothing there, it's not part of the domain, this is undefined. We can't do this composition because that negative 2 isn't inside a usable domain, okay? So we do get domain issues, happens a lot, but we don't have to worry about them too much now. We want to do example 1 here. We have some nice little polynomial functions, and I'm going to use colors here. So we have f of g of x. I'm going to write it f of, and what's on the inside? G of x, okay. And so it's saying, hey, we want to put something inside our f function. What is g of x? It's x squared minus 4. So what do? I have f of, and I'm going to replace g of x with x squared minus 4. Okay. Now, this looks crazy. What is this telling you to do? Plug it into the, yeah. It says, hey, go to your f function, where it is right there, and in place of x, what are we plugging in? Yeah. So I have something plus 7. And so instead of x, we are using x squared minus 4. That's what that's saying. It's saying instead of the x, you need to use x squared minus 4. Are my parentheses doing anything here? No, not really. So it's really just x squared, a negative 4 and a positive 7 makes a positive 3. So that is f of g of x. It's x squared plus 3. Nope, you're done. That's the answer. Yep, that's the answer. Let's look at the other one here. G of f of x, so I have my g function on the outside, and inside will be f of x. So g of f of x. Now, g of, so what is f of x? Yeah, so we can replace f of x with what it's equivalent to, which is the x plus 7. All right, now what is this statement telling you to do? Yeah, replace, go to the g function, and instead of x, what are we using? X plus 7, yeah. So my outside function here is something squared minus 4. And what do I put in place of the x? X plus 7. All right, so instead of x, we are popping in an entire function. Okay, now we do have to expand this What does x plus 7 mean for you to do? Double bubble it out there. We got x plus 7 times x plus 7. We got to FOIL that together. Yeah, x squared plus 7x is plus 14x, and then plus 49. And then subtracting the 4 on the end there. And just cleaning it up, we get x squared plus 14x plus 45? Yeah. All right. Questions on that one? All right. Let's look at we're going to do we're going to do this one, but we're going to change it. So we're going to change it so that you'll see this is what the delta mass are going to look like. F of x might be, so f of x is x squared plus x plus 3, and g of x is negative 3x plus 5. Negative 3x plus 5. So change those up for me, and then we can go ahead and do this stuff. F of g of x. And so what is f of g of x telling you to do? So what can I replace g of x with?
Negative 3x plus 5.
So there's my f, and instead of g of x, we have a little function, negative 3x plus 5. All right, now that tells you f of negative 3x plus 5. What does that tell you to do? Yep, go to the f function, and we're not using x's anymore. What are we using instead? Yeah, we're using negative 3x plus 5. So instead of the x's, we're plugging in. So you see what I'm doing there? I'm just sort of setting it up without the x's. And then we're plugging in a negative 3x plus 5. Everywhere there was an x. All right, once again, we have negative 3x plus 5 that we have to square. So negative 3x plus 5, negative 3x plus 5. We've got to FOIL that together. What does that give me if I FOIL that in? 9x squared. Minus 30x. Very good. Yeah, negative 15x and negative 15x gives me the negative 30x. And then we got a plus 25. We have the minus 3x plus 5 plus 3, and I just need to clean it up. So 9x squared, let's see, negative 30x and negative 3x, negative 33x's, and plus 33. Yep, 25 plus 5 plus 3 would be 33. Great, super. All right, last one here. God bless you. Here we have g of, what's on the inside this time? F of x. All right. And again, I take this one step at a time. A lot of teachers don't do that, but, you know, if you just work through it, it works out really well. What is f of x? X squared. Good. Plus x plus 3. Good. And so now this says go to the g function, and we don't want to use the x anymore. So instead of the x, we're plugging in this craziness. So I have my negative 3 instead of x. We're plugging in x squared plus x plus 3. And all we have to do here, distribute, yep. So negative 3x squared, negative 3 times x is negative 3x. And negative 3 times 3 is negative 9. And then the plus 5 dangling on the end there. So negative 3x squared minus 3x minus 4. Good? You think you can handle it? Yeah? Awesome. Yeah, I got delta math. Hey, that was like totally less than 20 minutes.